Hi, my name is Jatanadet Panyawat. I will present my project about the object detection. My problem setup is to predict multiple digit number by training MNIST which contain a single digit numbers. And this is the MNIST dataset. And this dataset that I try to predict is, for example, for is in the single image have 3 digits number, for example, 708. And then for 2 digit number in a single image is 45. And then for 111 is a 3 digit number. And this is for 1 digit number that I try to predict. Paper summaries. I have read 3 papers. First is RCNN. The state of the art is to of the RCNN is the object detection, and then is the multiple state computation. First, it's got the image, and then it extract the region proposal of about 2,000 regions, and this 2,000 regions of the image, it got fed to CNN structure, and then the CNN extract features of each ROI image and fed it to SVM to classify regions. Second, for the fast RCNN, a single stage computation. So we train both region proposal and original image together by extracting region proposal from feature mapping. And finally, from the feature mapping, we use softmax to classify the regions. This way, it's way faster than the RCNN because it crunch all the stage into a single stage. And then lastly, for the mass RCNN, it uses faster RCNN as a starter, a region proposal network RPN, and then it fed it to by ROI pool used to classify the region proposals. From faster RCNN, it added ROI align to increase accuracy of mass and also add a layer called binary mass of each ROI to not doing the rectangular box but do the shape of the object directly. In the implementation part, first I use selective search algorithm in OpenCV2 in order to select rows for my cases, but they have so many pictures, so many ROIs. Second, I create intersection area over mean area function to reduce ROI candidates. Third, I warping the rows candidates to input of CNN structure 28 by 28. There was 2 warping techniques. I used background adding and direct adding. Finally, I compute the image by using CNN. So this is an example of the ROI, and then I use the ROI and warping it directly. This is not look convincing that it's a 1, and then use the background adding. This is the using background adding and then we warping. This look more like a 1 more than the direct warping. So I have 7 layers of convolutional neural network structure. First is 2D CNN and max pool 2D, and then 2D CNN kernel 5 by 5 and use a ReLU to non-linearize the layers. And then once I do it 2 times, I make it more aligned to be 1 dimension and then do the linear mapping again, and then do a log softmax to predict the image. So conclusion, the warping with background adding was doing better than the direct warping, As you can see, 7, 4, 2, 9, 6, 7 is not quite correct. But this one, 7 is predict as a 6 and 2, 2 instead of 6 and 7.